Do you know artificial intelligence? No, really. Sure, you can type prompts into ChatGPT or maybe even develop beautiful, controversial art with no artistic experience whatsoever. Or maybe you can recommend NVIDIA stock to a friend. That's not too hard. Well, if you're anything like me, I really didn't know the answer to this question. I was monkey see, monkey do all over YouTube and was really interested in AI, particularly for investing. It seemed like an absolute no-brainer because of the obvious potential. And so I started doing my research so you don't have to. And rather than just throwing AI stock names at you and titling my video, "The 7 best stocks to buy right now, you will 10x your money," I want to give you the data and the information that will allow you to make the judgment. And before we get into it, I promise you 3 things. 1. You will understand the lingo, read the news headlines, and just talk about the space with more fluidity. Yo, how about AI, man? It's pretty cool. Yeah, for sure. ChatGPT, man. 2. You will be able to identify the companies that are leading the charge and maybe identify some dark horses in the mix. And 3, I will not waste your time. I'm not here to bore you with all the technical jargon and theory. That's what class and university are for. We will get just detailed enough to build that practical foundation. Let's get into it. Oh shit. To understand AI and what its capabilities are is simply not enough. There needs to be more context, and that's what this guide is here to do for you. What companies are really behind the innovation? What kind of technology is actually driving the AI boom? If it's not the chatbots or it's not the AI art generators of the world, then what is it? I introduce you to the 4 pillars of artificial intelligence. These pillars will give you the basis for understanding everything that goes into making AI applications possible, and who's in position to take advantage of the next generation technology. Let's jump into it. Pillar 1, computational power. Today, many of the electronics that you own run on CPUs, or central processing units. Think smartwatch, computer, phone, etc. The CPU is the brains of the operation and is responsible for processing and executing instructions. They perform these processes in order as they are provided by the user, so they can perform one task at a time. You do laundry, then you eat breakfast. However, what if you have a dual-core CPU? You can run 2 sets of instructions at the same exact time. Cool. Now you can do the laundry while eating breakfast. Impressive. So think 1 instruction set per core. You may have heard of quad-core or even octa-core before. The standard PC has anywhere from 2 to 8 cores, and that will be plenty of computational power for your average work. However, there are ways to take advantage of CPUs to enhance their performance and speed, also known as hyper-threading. And we won't get into the technicalities of hyper-threading because frankly, it's not super important for this discussion. The only thing that is important to know, hyper-threading allows cores to perform multiple tasks simultaneously. The more tasks we can perform at the same time, the better our computational performance. And we measure the speed at which a processing unit performs tasks in flops, or floating point operations per second. Simply think, the more flops, the quicker your tasks get done. It's the most common benchmark when measuring computational performance. In a study by California Berkeley, the top CPUs on the market today sit anywhere from 5 to 6 billion flops. They are quite speedy. However, surprisingly, billions just isn't enough. If we want to train an AI chatbot, we need something that will execute tasks even faster. In comes our next processing unit, GPUs. Now, GPUs were originally designed to accelerate graphics rendering by processing many pieces of data simultaneously. Who cares about this stuff? This is what we've been looking for. Because GPUs are specifically designed to process tasks simultaneously, they can run even faster than a CPU. In a world where chatbots and other AI models are competing for speed, the objective is to allow the software to learn as fast as possible. Think about it. Simply put, The more tasks the AI model can process per second, the more information it will consume, the more users will use it, and therefore the more moolah for the company. GPUs are really just specialized versions of CPUs. So we can see how incredibly important computational power is to the fiercely competitive AI market. Now that AI is requiring greater and greater computational speed, as we just discussed, GPUs are being modified and optimized solely for AI model development and deployment. Remember, GPUs were originally optimized for rendering photos, so even their speeds can be increased. These optimized GPUs are better known today as TPUs, or tensor processing units. And NVIDIA's most recent TPU offers a staggering 67 T-flops, about a 1000x in speed from the top GPUs. This discussion so far has been quite a simplification of the computational performance market, and there is a whole lot more tech jargon we could dive into, but it's just not super important for our analysis. The takeaway of Pillar 1, the faster, the better. Large companies want the fastest chips to stay ahead of the competition, and smaller businesses want the fastest chips to catch up to the competition. So we just talked about devices that can perform billions to trillions of operations per second. In order to perform trillions of operations per second, there needs to be some way to store these operations and hold them until they are executed. Meet the second pillar of AI, memory. Man, where would we be without our memory? Having to remember all the chores on the to-do list after a long day of work, all the errands to run when we get a few spare hours on the weekends, all the friends to reach out to that we haven't talked to since graduation, memory is important. And for a computer processing trillions of operations per second, it better have quite the robust memory. And it's important to remember these operations are processed in order. Here are the 3 most widely recognized forms of memory on the market today. On-chip memory is the fastest memory available and has the best power efficiency, but is typically unable to reach the bandwidth needs of AI models. For our purposes, we will focus more on the other 2 solutions. And with the increasing needs for AI applications to be used anywhere from your phone to your computer to your car, there needs to be a form of transferring memory remotely and quickly. People are impatient. Well, and if you're behind the wheel in a self-driving car and it's not able to get the information fast enough, then yeah, you might be in some trouble. Here's where the other 2 forms of memory really shine. Just know that these memory structures are extremely useful for many AI-related applications. They provide huge bandwidth and support very high data rates. Bandwidth being the amount or range of data that can be transferred, and data rate being the speed of data transfer. In other words, a lot of data can be transferred and quickly. Naturally, there's advantages and disadvantages to each of these forms of memory, considering factors like cost, implementation complexity, signal integrity, performance, data rates, bandwidth, yada yada yada. Just know some chips are more advantageous in applications than others. The takeaway from Pillar 2, it takes 2 to tango. An AI model is learning as quickly as it can, but needs to remember what it has learned. Fast processing speeds are absolutely worthless without robust memory. Before we move to Pillar 3, we need to rewind to key in on something that you might have missed. There needs to be a form of transferring memory remotely and quickly. Remotely, we need to transfer data remotely. If you are sitting behind the wheel of a self-driving vehicle, the vehicle must be pulling data from somewhere, from maybe some sort of database. You approach a stop sign, the vehicle is comparing what looks like a stop sign in its computer vision to what actually is a stop sign in its stored database. Where is all this data stored? The memory chips have to exist somewhere. Meet the third pillar of AI, cloud computing and data centers. I know when I was first introduced to the realm of cloud computing, I was pretty intimidated. but it's actually quite simple. Cloud computing is simply an exchange between you and a data center. A data center is a physical location that holds massive amounts of components that we talked about in the first two pillars, computational power and memory. Think data center equals very large and very powerful computer, usually many of them. Cloud computing allows businesses to essentially rent this computational power and memory in the form of pay-as-you-go pricing. Now, why is this useful and a key component of AI? Well, many companies that are building AI applications right now or plan on building them in the future don't want the hassle of buying, owning, and maintaining physical data centers and servers. It may just make more sense to utilize one that's already available via the cloud. It's very convenient. Like we mentioned, you have all of these additional assets, computational power, memory, and a massive database at your disposal, and you pay for it on an as-needed basis. Now, companies that want to dive into the world of AI can utilize cloud computing in data centers to get the necessary specs they need to do the job without spending hundreds of thousands of dollars and more on CPUs and memory chips. Let's look at AWS to give you an example, considering they're the dominating force of the global cloud market right now. As you can see here, AWS offers cloud solutions to all sorts of projects and industries. Nowadays, there's always going to be a need to store data digitally, and it's not always feasible to purchase your own assets. Albeit this pillar isn't absolutely necessary to build out an AI software, but it does even the playing field and provide affordability to those small businesses who are looking to be competitive in the AI space. Now at this point, we have reviewed 3 of the 4 pillars of artificial intelligence. Computational power provides the speed and performance needed to build out AI-driven applications. Memory stores and transfers the data effectively. Cloud computing creates affordable options for the first 2 pillars without having to physically own and maintain the hardware. These 3 pillars have really highlighted the necessary infrastructure to build out AI software. So naturally, they lead into our last component, pillar 4, software implementation. Now, when I say software implementation, I am referring to the thousands of AI applications that you see all across the internet today. More or less what every single video is about on YouTube. And this is actually one of the reasons and one of the inspirations behind this video. I felt like there was a gap between the tools and actually understanding some of the powers and forces driving this innovation forward. Anyways, all of these AI tools are utilizing the 3 pillars in some capacity. Artificial intelligence, remember, is simply machine-displayed intelligence that simulates human behavior or thinking and can be tailored to solve specific problems. And these specific problems, let me tell you, they can be very specific. Industries far and wide, from some of the most obvious being maybe finance through trading bots or online marketing through automatic optimization, to fairly more obscure applications like a hotel in Japan completely run by robots and velociraptors. And no, I'm not kidding. Google the Henna Hotel. AI models are trained using vast volumes of data at speeds that are simply incomprehensible to the human brain. This is why they are able to learn so fast. When you have a CPU that is processing trillions of operations per second and the memory capacity to learn from each and every one of those operations, you can see where the advantage lies. The discussion of whether AI will become super intelligent or not is for another time, but it is surely a valid concern and certainly one that will be monitored over the coming years. After examining each of the 4 pillars of artificial intelligence in more detail, you should have a pretty good feel for the language and the forces that are driving AI technology forward. However, this is just the first step. You may have came simply to build out your foundational knowledge on AI. That way you can talk about it with your friends, read and understand the hot news, and just stay in the loop. However, we can do so much more with this. As the old saying goes, during the gold rush, sell shovels. And whether you realize it now or not, these pillars, those pillars of artificial intelligence, are the shovels. Welcome to the new gold rush. I'll see you in part 2.